What's going on, everybody? In this video, I want to extend my talk about how to solve inequalities in one variable. And in this video, I'm going to talk about polynomial inequalities. So it's a little bit more complicated than the linear or absolute value inequalities, but I'm going to show you the processes in detail on how we solve problems that look like these. So let's say as a first example, I have x squared minus 6x minus 27 is less than 0. So the way that we're going to approach this is we're basically going to solve it almost the same way that we would solve this quadratic equation. So if I had an equal sign instead of a less sign, I would solve it the same way. And what we're going to do first is we're actually going to find the zeros of that hypothetical equation. So this one, what I'm going to do is I'm going to factor this. So I have an x here and an x here. Then the factors that I'm going to use are minus 9 and a plus 3. And then when I go to find the zeros, I have x plus 3 is equal to 0, x minus 9 is equal to 0. And this gives me x is equal to negative 3 and x is equal to 9. Okay, so you might be wondering why we're finding the zeros. So the reason that we're finding the zeros is because they make for great pivot points, because on either side of the zero, there's different signs. It's the point where the signs change, and that's going to be pivotal whenever we determine whether or not a certain value is going to be less than 0, because we're looking for negative values, and 0 is the inflection point. It's the breaking point of the sign. So that's where we find the two zeros. So what we're going to do is we're actually going to draw a number line out and then place these values on the number line here. So 9 is about right here. And that's going to produce several intervals for us. So don't really pay too much attention to the 0. I just like to have it on the number line as a reference. So the first interval that we're going to be looking at is this guy right here, from negative infinity all the way up to negative 3. Okay, so we're going to pick a value in that interval, plugging it into the original inequality and seeing if we get something that's less than 0. So here's what I'm going to do. I'm going to say negative 4. So negative 4 squared minus 6 times negative 4 minus 27. What is that going to give me? So negative 4 squared is 16. And then negative 6 times negative 4 gives me a plus 24. That's 40 minus 27. This comes out to a positive 13. So look, we are looking for answers that are less than 0. And a positive 13 is greater than 0 because it's a positive number. So what this tells me is that this interval is not valid. Any value of x that's in here is not going to satisfy the inequality. So we have to move on to the next interval. This produces a positive result, and we're looking for negative results. So now I'm going to pick a value in between negative 3 and 9. Represent that by this green kind of squiggly here, and see if it works. So the easiest value to pick is 0 because it cancels out two of the terms. And you can see if we pick in 0, minus 6 times 0, minus 27, these two go away. And then we're just left with negative 27, which is in fact less than 0. So I'll just mark that with an X. And this one checks out because it's a negative number. So we know that we have a negative right here and that this interval is good to go. So any number between negative 3 and 9 fits. And so the last interval that we need to test is this guy right here from 9 to infinity. So just pick any number that is greater than 9. I'm going to pick x is equal to 10 for this one. So I have 100 minus 6 times 10 minus 27. And guess what? This gives me 100 minus 60 minus 27, which is also 13, which we know from the first number that we tested does not fit either. So we get positive values for this interval right here, which lets me know that that interval is out. So the only interval that we have from our tests that are valid are all the numbers in between negative 3 and 9. And also keep in mind, our inequality symbol is strictly less than, so these endpoints are not going to be included. So to write out your solution in interval notation, we have that x is equal to the interval from negative 3 to 9. Any number that you pick inside this interval is going to satisfy the inequality. So for the next example that I have x squared minus 2x is greater than or equal to 3. So the way that I'm going to start this off is exactly the same as I did with the last example. I'm going to find the hypothetical zeros of this inequality. So I'm going to subtract 3 from both sides to move it over. So x squared minus 2x minus 3 is greater than or equal to 0. Okay, so I'm in a good position to factor. And this one is going to factor as x minus 3 times x plus 1 is greater than or equal to 0. And then to find the hypothetical zeros, I have x minus 3 is equal to 0. I have x plus 1 is equal to 0, giving me x is equal to 3 and x is equal to negative 1. So normally, if this was an equation, we would be done, and we've already solved it. But since this is an inequality, we have intervals of values that x can take on to satisfy it. So what we're going to do is we're going to draw the number line out. That was not very straight. That's a bit better. And you don't have to put the 0 in there. So I'm going to put negative 1 and 3. And then what this does is it divides the number line into certain intervals. We have the interval from negative infinity to negative 1. I'll mark this with a red line again. We have the interval from negative 1 to 3. Give that the green line. And we also have the interval from 3 to positive infinity. And we have to pick values in between these intervals that are a part of it to see if they're going to satisfy the fact that x squared minus 2x minus 3 has to be greater than or equal to 0. So we're looking for positive values. If it's equal to 0, that's fine too, because we know what values are going to give us 0 and they are included. Okay? So the first value that I'm going to choose is negative 2 in this interval right here from negative infinity to negative 1. So I'll have negative 2 squared minus 2 times negative 2 minus 3 and see if it's greater than or equal to 0. So negative 2 squared gives me 4 plus 4 minus 3 is 5. And this is, in fact, greater than or equal to 0. So we know that we get positive values for anything that we plug in to the first interval here. And so it's good to go. It checks. Now for the second one, the easiest one to pick is 0. And if I pick 0 here, I get 0 squared minus 2 times 0 minus 3. So if we plug in 0 here, both of these first terms cancel, and we end up with negative 3 is greater than or equal to 0, which we know doesn't make any sense. It's not true. So we get negative values for the second interval, which means it isn't valid. And then for the last one, I'm going to test an easy value. Let's do 4. So I've got 4 squared minus 2 times 4 minus 3. And this is going to give me a 5, which we know from the first thing that we tested is greater than or equal to 0. So we're going to get positive values for this interval, which we're looking for. So it checks out also. So we know that the two end intervals on this number line are valid solutions for x. So to represent that in interval notation, I'm going to draw the first interval, which is going to be from negative infinity to negative 1. And since we have greater than or equal to, this negative 1 is included. Then you unionize it with the other interval that is valid. So this one is from 3, which is also included, to infinity. And this is all of the values that x can take on. Okay, so in the next example, I've got 6x squared plus 5x is less than 4. So again, I'm going to start this one off by moving the 4 to the other side. So I have 6x squared plus 5x minus 4 is greater than or equal to 0. So in this one, I have some pretty ugly coefficients working. I got a 6 in front of the x squared term. It's going to be kind of a pain to factor. So I'm going to be lazy and just go straight to finding the zeros using the quadratic formula. So if I'm going to use the quadratic formula to find zeros, I have x is equal to negative 5 on the top, plus or minus the square root of 5 squared. which is 25, minus 4 times AC, 6 times negative 4. All that is divided by 2a. So 2 times 6 gives me 12 here. So if I'm going to crunch the numbers right here, 4 times 6 is 24, times another 4 is 96. So 25 plus a 96, this could give me square root of 121. And that just gives me 11. So I have negative 5 plus or minus 11 over 12 is equal to x. So my two zeros that I'm working with are negative 5 over 12 plus 11 over 12. And this is just going to give me 1/2. And then I also have x is equal to negative 5 over 12 minus 11 over 12. So negative 5 minus 11 is going to give me a minus 16. And minus 16 over 12 is a minus 4 over 3. So we have fractions for our answers. Don't let it throw you off. We're still going to do the same procedure. So I draw my number line. I'm going to mark negative 4 over 3 over here. And I'm going to mark 1/2 over here. And we're going to test the values that are created in these intervals. So I'm going to mark the first one with my red line, second one with my green line, and the last one with my blue line here. This is just the way that I like to divide them up. So I'm going to pick a value that is along the red portion of my number line here, and I'm going to pick something easy. So I'm going to pick negative 2 for x and see if I get a result that's less than 0. So I have 6 times negative 2 squared plus 5 times negative 2 minus 4. So negative 2 squared gives me 4. 4 times 6 is 24. Then minus 10 minus 4. And this gives me a positive 10. Is this less than 0? It is not. So we know that we're going to get a positive value for this interval, which is not what we're looking for. We're looking for things that are less than 0. So we know the first interval that we test is not valid. So for the second one, I notice that I have a sign change, which means that 0 is inside this interval, meaning that's the one I'm going to test. So I'm going to pick 6 times 0 squared plus 5 times 0 minus 4. And as you can see, the first two terms are going to cancel, and I'm left with minus 4 is less than 0, which is a true statement. So I'm going to get negative values for the middle interval, which is what we're looking for. The middle interval is valid. And so now I'm going to pick a value along the blue portion of the number line, and I notice that I can choose x is equal to 1 for this. I have 6 times 1 squared plus 5 times 1 minus 4. So this is going to give me 6 plus 5, 11, minus 4 gives me a positive 7, which is definitely not less than 0. And what this means is I'm going to get positive values for this interval over here, meaning that it is not valid as a solution. So the only values that x can take on are the ones in between negative 4 over 3 and 1/2. So that is my solution. So the interval, remember I'm using strictly less than, so neither of the endpoints are included. Negative 4 over 3 to 1/2, also not included. And this is your answer. And this is the last example that I'm going to do for this video. So again, I'm going to start off by switching the 15 to the other side. So I have 2x squared plus x minus 15 is greater than or equal to 0. And then I'm going to solve this guy by factoring, or at least try to. So I'm going to have a 2x here, an x right here. And then I'm going to choose 3 and 5 from my numbers. I'll have a minus 3 right here. So I'm going to have a plus 3 right here and a minus 5 right here. And set it equal to 0 to find the zeros. So 2x minus 5 is equal to 0, and I have x plus 3 is equal to 0. And when I solve for x, I get x is equal to 5 over 2. X is equal to minus 3. So these two zeros are going to be the pivot points that we have on our number line. So I'm going to mark the first one, negative 3, and the second one, 5 over 2. Again, this is my red portion. Mark this one green, and I'll mark this one blue, just to just to just to give discretion over the different intervals that we're testing. So I'm going to pick a number that's along the red portion of my number line to test. So I'm going to pick negative 4. So I'll have 2 times negative 4 squared plus negative 4 minus 15. And we want a value that's going to be positive or equal to 0. So we're looking for positive values. So 16, negative 4 squared is 16 times 2. It's giving me 32. Minus 4 is 28. Minus 15 gives me a 13, which is greater than or equal to 0. So we know that our first interval is going to give us positive values, which is what we're looking for. And in the second interval, I notice a sign change. So I'm going to plug in x is equal to 0. No need to be fancy. Don't be cute. Just pick easy values so that you don't mess up any of the arithmetic. So in doing so, both of these terms cancel, and I'm just left with a minus 15, which we know is definitely not greater than or equal to 0. So we're going to get negative values for our middle interval, and it's not going to work because we're looking for positive values. And then for this guy, I'm going to pick x is equal to 3. So 2 times 3 squared plus 3 minus 15. Let's see what I'm going to get. So 3 squared is 9 times 2 is 18. 18 plus 3, 21. 21 minus 15 is 6. So I have 6, which we know for a fact is greater than or equal to 0. So we're going to get positive values for our last interval, which is what we're looking for. So x can be the two end intervals that we have on our number line, So to represent that in interval notation, I'm going to write the smaller interval first, which is going to be from negative infinity all the way up to negative 3. And since we have a greater than or equal to symbol, this endpoint is included. And it's the same story for the other interval. So I have 5 over 2 as my lower bound, and every number greater than that is also valid. So I hope this video was helpful about how to solve polynomial inequalities. The next video I make is going to be over rational inequalities, and then I'm going to move on to start talking about functions and how to graph them and things like that. So I hope this video was helpful, straightforward, easy to follow, and it helps you out in your math classes. And stay tuned for the next one. Take care, everybody.